Okay, so I'm just going to make a short video going through some of the kind of most common maths questions that come up in mechanics in 5th year. So this is similar to what we've done in class, just the main points and some examples of years where those questions come up. So the first thing I'm going to talk about is vectors and your SUVATs. So normally these two come together. So what I'm going to do is I'm going to talk through the main points and then give you some exam questions. I'd just like you to pause the video and go and do those exam questions, and then you can come back to the next section. Okay, so if we use a vector of size f, let's say, that's at an angle, we should know at this stage that if I want to break up this vector into its horizontal and vertical components, we just learn off through trigonometry is where it's come from, but we learn off that this will be f cosine of the angle, and this one will be f sine of the angle. Okay, so just to be clear, the reason why this is cosine is because this one is closer to the angle. So if I give you another example, let's say I have a vector of size f, and it's at a certain angle to the vertical component. This one will now be f cosine theta, and this one f sine theta. So when is this actually useful? Well, one of the places that we see this most often is when we have an object on a ramp. So let's just have a look at that. If I have an object on a ramp and it has a certain weight, we know weight is a force. If I want to find the component of the weight that's acting down the ramp, I need to break up that weight into its two components. Through trig, this angle here is equal to this angle here. So you should be able to see then, if I have this weight here and this angle here, this will be weight cosine of the angle, and this will be the weight sine of the angle. So normally with questions like this, you might actually be given the mass rather than the weight, and we just know that the weight is mass multiplied by gravity. Okay, so that'd be mass by gravity by sine theta to get the component of the weight acting down the ramp. Right, your SUVATs, which again are in your log tables, you don't need to learn them off. V is equal to U plus AT, V squared is equal to U squared plus 2AS, and S is equal to UT plus a half AT squared. Right, there are your three SUVATs. Normally you're going to be given a story and it might have several different parts to it. So it could be that a guy jumped out of an aeroplane, fell for the first while, then he opened his parachute, and so on. So what you will find is that you need to break up the story. So for example, if we use your man that jumped from the plane, he started, U would be 0, and then V would be his final velocity before the parachute opened. Then once the parachute opened, that V will become your U for the second part. So break your story up into the different parts of the story and then work out your V, U and AT for each individual part. Okay, a lot of the time what you're going to get is that you need to work out the net force. F net, or resultant force, is just the mass by the acceleration. And you can find out the net force by taking one force away from another. So for example, if I have a car that's accelerating, I'll have a driving force minus the friction, so that it'll accelerate forward. So F net, the mass by acceleration found through SUVAT, will be equal to the driving force minus the friction. If I have an object that's moving down a ramp, it will be the weight, the component of the weight that's acting down the ramp, minus the friction. So each time you're using this. Okay, so some years that this comes up. We have Higher level 2007 12A. And we have 2009 question 6. Okay, so for ordinary level, you have 2017 12A and 2008 12A. So what I'd like you to do at this stage is pause the video. You should have these notes taken down, and I want you to attempt the 2 questions for whatever level you're on. Okay, so the next thing that we're going to talk about is momentum. Momentum questions normally aren't that bad. The problem is people often forget that momentum is a vector. A vector meaning that if we have, for example, a ball moving in this direction and another ball moving in this direction, the velocity of this will be a plus and the velocity of this will be a minus when finding out the total momentum of the 2 bodies. So normally your question just involves mass by velocity plus mass by minus velocity. And if you're doing a conservation of momentum question, it will be equal to the mass by velocities of the bodies after the collision. So yeah, again, main thing, just a vector. Make sure if they're moving in opposite directions that one of them has a minus sign. So again, I'll give you some questions to do on this. Okay, so your higher level, you're going to do 2002 question 12A and ordinary level 2007 12A. Again, you can just pause at this stage after momentum and do those questions. One thing to note is in the higher level question, it asks you to define momentum. Often in physics, when it asks you for a definition, it's not just for the crack, it's because you're going to use that in your calculations later on in the question. So you're going to use momentum in doing that 2002 question. Okay, so moments is the next thing we're going to do. So the moment of a force is equal to the force multiplied by the perpendicular distance. Now, this becomes particularly important sometimes in tricky questions. It's the perpendicular distance. So if I give you an example of a tricky question that came up, and I'll actually get you to try this question. So if I have a weight hanging off this here, the moment there will be tension in this string here, the moment of that force, that tension, would be the tension multiplied by this perpendicular distance there. Okay, so that will bring us on to what we need to talk about, which is equilibrium. When an object is in equilibrium, forces up are equal to forces down. The clockwise moments are equal to the anti-clockwise moments. So there is a question based on equilibrium, and there's a diagram like this. You would have, if you imagine, I cannot act it out here, but this is pulling down this way. So it's pulling clockwise. This string is pulling that way, so it's pulling anti-clockwise. So force by perpendicular distance from the turning point, force, the tension, by perpendicular distance from the turning point. So that's your kind of hint for going about that question. Other questions that come up, generally speaking, are some weights hanging off a meter stick. I would always suggest drawing your little diagram, and note that there will always be an invisible weight. That invisible weight will be the weight of the meter stick, which doesn't necessarily act through the 50 centimeter mark because you might not have a uniform meter stick. If you're not told where to do the distance from, about what point, choose the 0 point, because it's very easy to find out how far away 20 centimeters is from 0, because it's literally just 20 centimeters 89 centimeters, and so on. So you don't have to do much maths. So choose 0 to be your points that you do it about unless you're asked. And that's your invisible weight. Okay, so again, the questions that I want you to do: ordinary level 2006 12A and 2003 12A, higher level 2011 question 6 and 2017 12A, which is based on that picture that I drew over here. So you can pause and do them. Okay, so we're getting there. So density normally comes up as a question 5, so a short question. Your pressure, what's commonly asked is your Boyle's law definition. Boyle's law says that for a fixed mass of gas at a constant temperature, pressure is inversely proportional to volume. Another way of writing that is PV is equal to K. So pressure multiplied by volume is always equal to the same number, a constant. Or another way, which is the one we're going to use in the maths, is P1 V1 is equal to P2 V2. The pressure and volume at the beginning is equal to the pressure and volume at the end. This is used a lot in the calculation questions, particularly in the ordinary level. It's come up quite a good bit there. So again, I'll give you some questions where you do them. Okay, so there's your ordinary level 2 questions, and there's your higher level 2 questions. And the other thing that can come up with pressure a lot of the time is pressure in a liquid. So this is your formula for it. So pressure is equal to, this is the density by gravity by the height of liquid above it. So again, that comes up a few times. So I'm going to give the ordinary level a question where this appears. Okay, so again, you can pause and just do those questions. And now the last topic that we're going to talk about. And again, there is some other stuff which obviously haven't been mentioned here. This is just a nice summary of the main points that come up in mechanics in 5th year. But we're going to talk about energy. So what you'll find is you might have SUVAC questions or other parts of the course mixed in with this. But basically what you should notice is if ever there is an object or a person which is changing in height. So for example, someone on a roller coaster, they're changing in height. If you have a pendulum which is moving up, they have changed in height. If you have a pole jumper, I think came up in another year, they're changing in height. That should be your hint that you're probably going to use the conservation of energy, not create or destroy, but change from one form to another. So you're probably going to be using the kinetic energy is equal to potential energy. If an object is up high, it has potential energy, it loses that potential energy and it gets all converted into kinetic energy, providing there's no sound loss or etc. So your formulas you're using are half mv squared is equal to mgh. So again, I'll give you some years that comes up. So that's ordinary level 2010, question 6, higher level 2018, question 6C. And that is a short, though you might not find it short listening to me for this long, but it is a short summary of mechanics in 5th year. So that's the page just there. And if you've managed to listen to me for this long, well done, guys.